Ladies and gentlemen, it's time to start our last session of today. And it's a real pleasure to introduce to you a quite unique guy. I'm going to tell you why he's unique in just a couple of seconds. Edson Yanaga.
Hello, everybody. It's a great pleasure for me to be here for the first time in Sweden. And I have to tell you, it has been an amazing experience so far. I've never seen snow in my life, so I got to see it yesterday. I never felt so much cold in my life, too. So that part I'm not enjoying that much, okay? Because I came from a very warm place. I'm a Brazilian Japanese. So when I left home, it was kind of 30 degrees Celsius. So I came here, it's like minus something. So it has been different. Yeah. But everything, the people is great, the food is great, everything is great, except for the cold. But the snow is cool. I was able to even make a snowball yesterday for the first time in my life, and I felt like a child. I was smiling by myself. Today I'm going to talk about effective and clean Java code, tips and tricks for the real world. I've been talking to people in different companies, ranging from small startups to large e-commerce and banking institutions. And I've collected some tips and tricks from the past 20 years working with Java code, legacy Java code, new Java code. And I've selected some of these tips to be showing you today. So, of course, I wanted to show something new that I haven't presented before in other conferences. So I've spent the past 2 days working on a new demo. And of course, I wanted to use the latest versions of everything that broke everything. So I was fixing API compatibility things during the whole day. But it worked like half an hour ago. So I'll be able to show to you. Okay? And I'm a director of developer experience at Red Hat. My Twitter handle is @Yanaga. And I'm also a Java champion and a Microsoft MVP, which is kind of weird to be talking about because some years ago it would be an impossible combination. But I've been a Java champion since 2015 and a Microsoft MVP since last year, mainly because of the work I've done with the Microsoft people trying to enhance their Java support on Microsoft Azure. So I'm a Microsoft Azure MVP. And as usual, always trying to improve the Java world for us, Java developers, so we can have another option as a cloud computing environment to be deploying our applications. And I would like to start my discussion here saying that software is a craft. I know some people, we can call ourselves software engineers, but I always like to think about that as a craft because we never do the same software twice. Even if we were paid to do the same software twice, we would do that differently in the second time. We would have more knowledge. We would have to apply different techniques. We would want to produce something different, something better. And maybe that's one of the definitions of the craftsman. We're always spending some precious time of our lives to produce something that in most we can consider to be unique and to be useful to somebody. I always like this quote. It's on the Computer History Museum in Palo Alto, I guess, which says that computer programming is an art because it applies accumulated knowledge to the world, because it requires skills and ingenuity, and especially because it produces objects of beauty. Yeah, for us programmers, probably there are very few things in our lives that are more beautiful than a very specially crafted code that solves a real-world solution. And better than that, something that makes the user, the eyes of the user shine when you really provide some value to them, when you're solving some kind of real problem for them. But besides all of the discussion about software craftsmanship, I also like to emphasize that, as Jordan Appello said in Management 3.0, no matter what other methods you apply to achieve competence in a social system, in the end, it all depends on whether people actually care. So it doesn't matter how much you study, it doesn't matter how much time you spend on something. If you want to produce something that is really useful, really good, you have to care about what you're doing. And we know software changes people's lives. It can change people's lives for the worse, because we know that feeling when we're miserable using software that doesn't is done up to our expectations. But we also know what is to be delighted when something was very well done and it works for us. And the question that I ask myself every day is, why would I have to choose to make somebody miserable when I can make people be very happy with my work, with what I do? So some years ago, I've had taken this path for me. I've chosen to be a software craftsman because I used to be one of these stupid, arrogant bastards that was just complaining about everything. Especially because I use it as a consultant and with junior programmers most part of my life. I was just bashing people. Oh, this is crappy code. This doesn't work. And I realized that it's just stupid for me to be complaining or blaming someone for doing something that I believe it was wrong, but I never said what was the right way. So I decided to change that. So instead, I believe that everybody is doing their best because everybody cares about what they're doing. And one of my missions, in fact, one of my life's purpose is to be able to at least try to help developers worldwide to craft better software and to deliver it better and faster into production. So that's why I've collected some tips here for you today. I hope they will be useful in some cases for you. I'm going to talk a bit about domain-driven design, which is one of these amazing concepts that, unfortunately, not everybody grasps until today. It has been more than 10 years that the book was written. And to be honest, I've read this book a few years ago, and when I finished it, I realized that, oh, that's an amazing concept, but I have no idea how to apply that into my code. So I spent years and years trying to figure out a way to transform that concepts in code. So I think I might have some clue now that I want to show you today. And not only talking about domain-driven design, I also have some code smells that I would like to share to you. First of them is primitive obsession. We're just used to our anemic domain model. We just create our entities, our aggregates, our classes in our code. And usually we just use the plain primitive types that our language provides to us. We're just using string, integer, big decimal, and this basic date, local date. These basic types, and maybe it's time for us to do something different. A great article written by Martin Fowler in 2003, and it's very current today, is When to Make a Type. But basically, he says it was published in an ACM publication. But basically, he says that if you're in doubt, if you should be creating a new type, a new class, in your system, if you have this doubt, then you probably should, because it's much easier for you to remove a type later than introducing a new type later. So instead of just getting your business logic scattered through a lot of different points in your system, possibly with the application, you should be creating a type to self-contain this kind of behavior and state. Another thing that we would like to tackle today is the damn null pointer exception, because that's the #1 exception in the Java world, and not only Java. I believe that everybody suffers from the null pointer exception. I know there is some kind of bike shedding in the past years or months. People like null, people don't like null, people prefer optionals, which is controversial. Some people like, some people dislike. Some people are asking for union types, which is another way of solving the exactly same problem. So I guess that all of the solutions are valid. It just really depends on where are you applying them. So I'm going to propose just one particular way that I believe that in this use case that I'm going to show you is useful. So we're going to deal with null pointer exceptions in a different way in this particular use case. But instead of just saying to you the things and the concepts, I would like to do some live coding. You know, it's always a challenge to show you some live coding, and I hope it works. It was working on my machine at least 30 minutes ago, and I hope it will keep it working. Okay, so let's start with our domain. Sometimes we want a domain. I'll start with a very simple example. I'll just try here, and I'll make this code available on GitHub later. Just have to commit it later. So let's create order. Order is an entity because I want to handle that with JPA, with a Java EE. That's a Java EE environment. By the way, I'm going to show you a demo running on Wildfly Swarm, which is a FatJar implementation, Java EE compatible for creating microservices and monoliths too. So we're going to create here an entity. It has to be serializable. It also requires an ID. It has to be an ID. It has to have a generated value. Okay. An order must have a number too. And what else? Must have a constructor. I'm not a particular fan of constructors, so I always prefer static factor methods. So static order of when we have to create something and return new order. Okay. First consideration, why should we be doing the static factor methods? Because I believe the syntax is cleaner, but that's not enough, but mainly because I think it's also safer to create our objects. And we can have some optimizations where we're using static factor methods. For instance, if that's the only point of my code that is able to create an instance of order, then I can craft some validations here, so I won't allow any order that is invalid in my system to be created. So let's say that number should be a not null value. Okay, but if you allow somebody to just create a new order and just leave the order number empty, then we would have a consistency problem. Then maybe I could just be using integer number and be using, like, I like the Google Guava library a lot, so we can use some static methods here to check that my number must not be null. Yeah? Check not null, so if I try to create a number and provide it a null reference, then it's gonna have, in this case, a null pointer exception right here when I create the object instead of later when I use the code, which is much harder to debug. In which part of the code I allow it to create an order with a null order number. So another thing that we can do here, maybe number can't be a 0 or can't be a negative number, so I would have to check the argument here. So if I know that it's not null, then maybe I can check a number greater than 0. So that's one of the conditions that I could be creating here when I create an order. So, but it makes it can generate some kind of discussion. Why do I allow an integer to be part of my domain model? Maybe I could enhance it and decide that maybe order numbers should be printed on the screen in a different format. Maybe it should be 2 digits dot 2 digits dash another 2 digits. Maybe I could be able to parse it when somebody scans a barcode. And this kind of logic usually gets scattered through a lot of different points. And somebody that tries to implement a new functionality don't know that somebody already implemented this kind of validation or formatting in another point. So you just get duplication and errors and everything else. So maybe the responsibility for knowing how to parse and how to show, how to print the number should be from the number itself. So instead of just using a primitive here, I'm going to create another class, which is called order number. Let's create this class. And if you're using to domain-driven design terminology, my order should be an entity, which later we will explain. It's not just an entity, it's an aggregate too. That's an aggregate to root. And order number is something what we call a value object. Yeah? What's the difference between that? Entities, usually they have identity, which means that if I model a person class, and this person later changes his name, changes his sex, changes its address, and everything else, it's still the same entity. Okay, so its life cycle is longer. It represents something, and even if all the attributes are modified, it still represents the same identity. Value object, on the other hand, they can be replaceable. So it only matters for a value object its current value. So if I have a phone number, which with number 222, and another phone number with number 222, if I compare one to the other, they are the same, they're equal, and I can exchange one for the other. Okay? So order number, it doesn't matter for me, it's identity, they're just replaceable. So let's create a value object here of an order number. Maybe internally I want to store it as an integer too. So I'm going to create a value here. Since it's final, I have to provide a constructor. And since it's a constructor, I don't like constructor too. Here, then I'm going to refactor, extract. Oh, come on. Factor methods, I like off, but of course it's just my choice. Then I can provide here this, again, check not null. value, and check argument, number greater than 0. Okay? Oops. Value greater than 0. Okay, I've checked it here. Of course, all value objects and entities should be provided their all equals and hashcode methods. I'm gonna just do a quick implementation here for you to check. Object instance of order number, instance of order number, order receives cast, return. And thankfully, in Java 8, we can use equals. Oh, right. Thank you very much. It means you're paying attention. I really appreciate that, okay? Value. Okay, order number. Order number, okay? In the real world, we would have be crafting some tests to check that. I won't be doing that. I have an excuse today because I'm live coding. Yes. Okay. Object dot oops. Hash. Okay. Then equals hashcode. Maybe I can provide a toString, which I would like to remind you, toString should not be used to print things to the user. It should be just mainly used for debugging purpose. I want to know the value of the object, etc. Maybe I can just integer.toString and pass the value. Or since value is already an object, I could just type toString here. If I want to format the value to be provided to the end user, there's another interface in Java which is called Formattable, which provides very nice formatting capabilities. I strongly suggest you to take a look at documentation, because that's the method that is called when you call string.format and pass something to that. You can pass parameters. You can use them inside here. So if you want to format that 2 digits dot 2 digits dash something, you can do all of that here. So you can also have alternate formats, and it's very, very, very flexible. Also, you can provide some internationalization code. If you want to use dots or commas, everything else, you can do that all here in this method format too. So here I'm just gonna format value. Okay. Just so you can use the standard syntax for string.format here too. So that's one of the things that we can use when creating value objects. We could implement comparable, we could, or everything else. It really depends on what we're trying to model in our code. Okay. So here, order number, I just have to check now if it's order number. Maybe I can provide a number, and then I check if it's not null. Then I can create another constructor, passing the value, so I can guarantee that I'll never create an instance which has a null order number. So, but JPI specification requires you to have a default constructor, so we're not going to get rid of this protected constructor. But maybe we can create another private constructor. Order, oh, come on. Number. Receives number, right? Yeah. Some people say that mutability is the new go-to. In fact, the hardest things that we have to debug is how did my class get into this state? So you usually have no clue because our systems are running for a long time, and when we find some kind of inconsistent state, it's very hard to know which was the source of this mistake. So it's much better if you try to minimize the mutability. The less mutable our code is, the safer too. And here, we can't, in JPA, provide like final fields. In fact, we can, but it's not that easy, not practical, and everything else. But we don't have to make the fields final to provide immutability. We can make immutable code if you guarantee that nobody's changing the state outside our class, and also if nobody's changing our state after we created the object. Okay, so we have to be very judicious if we want to provide mutability or immutability to our code. And I also, most of the times I've seen people, ID or the number, let's just generate the getters and setters for everything and expose my code, okay? Then we're just using data holder. Order is just a data holder because anybody can simply modifying my internal state externally and then set a new value is not a safe practice to be doing that. So instead of just allowing people to be creating the getter setters, I like to digest a bit. Should I be providing a get ID? Maybe. Maybe I'm not showing, I'm not using that anywhere. Maybe, but sometimes I want to debug and I want to know the ID information. Then maybe you should be providing a meaningful two-string method to be useful in your debugging. So get ID most of the time is not useful because you shouldn't be exposing your primary keys anyway. But number, definitely I want to show this information to my user. So maybe I could be using an order number here. Right? But no order, usually an order has no value if it doesn't have any items. So I'm going to create what here? I'm going to create some list of order item. It has to be items. List. Okay. Then here I'm going to create another class, order item. Then we start another discussion. The basic thing, everybody usually does that the same. I'm going to create order item. Maybe I could create an entity and everything else, but then I have to ask you if order item, if that's an entity, I mean, does it have an identity or is it just replaceable? If I have an item, an order item inside my order, and it's a t-shirt of size large and it costs me for Swedish crowns, right? That's too cheap, probably. But if I replace this order item with another order item with the t-shirt size large, which costs 4, does it make any difference between them? I think they're replaceable, so they're not supposed to be entities. They're supposed to be value objects. How do I map that into my domain model using JPA? Then I guess they shouldn't be entities. They should be embeddable. They shouldn't be providing an ID. So I could private integer amount, private string product. I should be creating classes and reference for all of this, but I won't be doing that because I won't have time, but be aware. And I could be a big decimal price. I could be doing that. Again, I don't want to create just plain default constructors, but because of JPA, I have to. So I have to create here order item. But I can also create a constructor when all of them are required. I should be creating another refactor. Oh, come on. Replace constructor refactor methods. And I have here. Then again, I could be able to check can be null. Amount, I'm going to import that, check not null product. But I would be creating all kinds of validation inside each one of my value objects too. And in this case, maybe I want that to be immutable because I'm never going to change an order item. If I want to change something, maybe I will create another one, remove this one, and replace that because they have no identity. Then I can create here. Instead of creating getters and setters, I'm just creating getters because I want my class to be immutable. Then I'm going to provide that in my order class. I have here a list. And instead of providing that one-to-many mapping, the other side would have to have many-to-one, I can provide them as element collection. Okay? It allows me, now that's an entity, order item is a value object, it's replaceable and everything else. But my class has still too much mutability because I have to get these items and expose that to a beautiful screen so the user can see all of his items and everything else. So I have to expose it in some way. I'll have to create a getter. But I won't create a setter because I don't want anybody to be allowed to change my items except for my order class. I also don't want people messing with my list here. That's why I won't be providing the items list. I'm going to create a copy. Copy of items. Immutable list is an immutable list implementation provided by Guava, which is very useful in this case. So we're just copying the items, and nobody can change my list. If anybody tries to add or remove something, it's going to get me an unsupported operation exception. So I have it protected. So with this code, nobody can change my items except for my order. Okay, so I have to provide some way for people to add items to my order. I would have to provide an adder method, add item. I can provide an order item. Okay. Then they would have to check if that's not null. Then if everything is okay, maybe I want to add that item. Okay? Then it provides to me. Then the only point in my system that allows my list to be modified is this adder method. So it's a very basic behavior here. But later you decide that when I'm adding items to my order, if somebody tries to input a duplicate product with the same price, I don't want to have two different items, with one with 2 t-shirts, another with 3 t-shirts as an amount. I want to add, I want to have just one row with 5 items. So the product and the cost, the price are the same. I don't want duplicate items. I want to fuse them in just a single one. If you didn't care about providing immutability and providing a single point of interest in your code to modify the list, maybe you would be just searching in your code. I want all of my references where my list is being changed. So that would be very messy, but instead now that the only entry point is add item, maybe I could add some logic here. If item contains something, I could add some custom logic. If I find a duplicate product and price, then I remove the current item, create a new one, add the value, and just replace it. So it's much safer to be doing my code this way. Okay, that's some of the consideration that I might have. Okay, let me check the time. How much time do I have available still? Sorry? Half an hour? 25, okay. Oh, then I can show you more things. Okay. Then I have item, usually, and that's a polemical thing that I want to show you now. So items, maybe sometimes I have the order item, I just have the regular items, and for some reason I could be using a shopping cart and I want to represent the abandoned items too. I'm going to reuse the order item in this case, because I just can move it from one collection to the other. Order item. And in this particular case, I want to show you, it's very specific. Maybe I could duplicate the list and provide the get items, get abandoned items too. But then if I don't want to break the meters law, then if I want to check how many items do I have and how many abandoned items do I have. Maybe I would have to create 2 different methods like this. Public int get amount of items. Then I would return items dot size. Then if I wanted the abandoned items, amount of abandoned items. Yeah. So for each one of the information that I would want to expose related to my items, I would have duplicate methods, duplicate logic. Maybe I would want to sum total amount of items, get public big decimal, like get total items of items. And then I would have to just create items dot stream dot map item get order item get price, then reduce big decimal dot 0 big decimal add. Okay, then I can and return that. So just getting all of the prices of the items and returning the value. Then if I wanted that for the abandoned items, I would have to do that the same again and just copy and duplicate code. Right? Abandoned items. Yeah. Yeah. Now that's the polemic part. That's the way you should model using the mirrors law. Sometimes, particularly, I had just one opportunity that I thought it was worth considering this kind of refactoring, I was thinking about maybe the total of the items, the total price, the total amount, the total quantity of the items is not something related just to the single item or to the order by itself. Maybe it should be some information that could be provided by the collection of items inside here in my code. So instead of just using plain list implementations, maybe I could be creating another class, and that's instead I could create an order items. I could be creating another implementation which extends. I can create my own list and my own collection for the list. Then, oops. We just have to implement these methods. Public. I can internally, it's going to be a list of order item value. I'm going to make it final 2. Then it requires a constructor. Then I'm going to refactor that. It's hard with big fonts. Off. Then again, I can check not null. Value, okay? Then we're going to return delegate. I'm going to return this list. And if I want to provide, maybe I could, instead of just be duplicating my code here, and all of the lists, total of items, maybe I could just be open order items, and be creating this method here. Oh, come on. Public, big decimal. Get total. Return value dot stream. Okay, that's one possible implementation that I could be doing. And if I wanted other kinds of properties, maybe I could be using and creating another methods just to eliminate duplicate codes and having a cleaner API instead of just having a bulky API with lots and lots of methods. Of course, I only recommend for you to consider this option when you have many different properties related to the set of the order items. And you usually have more than one list with the same kind of value objects. And you don't want to have a huge bulky API with repeated code and everything else, so you can just have one place to debug, to code, and to test. Right, so if I remove here, now instead of just returning get amount of items and everything else, I can, here in my get items and get amount of items, I'm going to return order items. And it's not a mutable list.copy of, return order items of items, okay? And I could be doing the same here. Get abandoned items. Right. I think I forgot here. I don't want to receive here. I want to create a copy. Copy of value. Okay. So I can guarantee that it's immutable too. So that's one approach. That's controversial because some people were asking, but you're breaking the mirror law. I know, that's why I say that's a special case, which is worth considering sometimes, but most of the times you wouldn't be needing to do such kind of thing, but that's a possibility. Just for you to be aware, you're not constrained to just using plain list or sets and everything else types for you. In fact, I could have even named order item list as my class, but that's a bad naming strategy because I don't want to expose that my custom type is a list, because later I want to change that for a set or for a map, depending on what I do. So we shouldn't be bounding our types here in the custom types that we want to provide, right? Order items, so items, okay? So other things, so we have custom types, we created a custom list, which I'm forwarding and then reaching that. So I'm creating a richer API at the cost of creating Demeter's law here in this exactly same point. But this code won't work in JPA yet because JPA doesn't know how to map this kind of custom types to my database. So I'm going to create, thankfully, in JPA 2.1. Now we have the attribute converters. So I'm able to create an attribute converter. I create the order number. I have to create a class to instruct JPA how to convert my order number into something that is able to save through JDBC, through JPI. So I have to implement an attribute converter interface. It has generics. The first parameter is the type that I just created, order number. And the second parameter is the type that I want it to be interpreted to be stored in the database. So I guess I want to convert that to integer. And I'm going to implement this. If I want JPA to auto-apply this converter in all instances that he found in my classes, then I can add this annotation, auto-apply, true. Then what do I have to do? Attribute. I know, I think the specification requires it to be null safe, but I had issues in the past, so I'm playing on the safe side. I'm testing it. We'll discuss later. So attributes. Now I need to return an integer, but since my value is encapsulated, I have no way of exposing this information to my database. So now we have to make a choice. We have to expose it somehow. Some people would just attribute return get value. Okay, that will be the first thing that we'll be doing because order number already has an internal value property. I don't like get value because I think it exposes my internal representation. Instead, I'm going to provide public integer to integer because this way nobody can tell exactly which is my implementation. Return value. Integer is immutable, so it's safe for me to provide. Later, I could be providing a too long or too big decimal or too something else. I could have multiple methods in my implementation. So here, I get to integer. So I'm exposing the value as an integer to be stored in my database. And here, in the opposite side, when I want to read from the database, if dbData null, then it should return null by default. Then return order number of dbData. Okay, that's one of the ways you can do to map your value objects. Your value object like order number, not like order item, because it's going to be handled by the embeddable attribute of JPA. So this way you can convert your order numbers to the database back and forth. So that's the default implementation. And you say, I'm getting to the data, I'm interfacing with the database, but not always, but usually you have to interface with a view technology. Lately, most of the people are developing like Angular or React applications, and you're just exposing your code, your Java code through REST APIs. But REST APIs, we have mapping technologies too. The demo I'm going to show you today is based on JSF. I know some people here hate JSF. I don't hate it. I don't love it neither. But I think that sometimes JSF is the perfect solution for a specific problem. Sometimes I think also that's the worst possible solution for some kinds of problem. But I'm going to show you that just because it's simple, because it's plain Java EE, and because JSF also has a very simple converter implementation where I can get my domain model to be exposed to the user back and forth. So I can use JSF converters too. So that's one of the things that I wanted to show here regarding how can we map some entities, aggregates, and value objects regarding JPA code. But now I want to show you. Okay. Right. That's its presentation mode. Let me be again. Just want to open my browser. Then I wanted to create a full Java EE application with just some steps so I can access the wildflyswarm.io website. It's showing? Right. Can access here the generator. And the implementations that I chose to show you today, I could create in here artifact demo Jfokus demo. I wanted to use JPA. I wanted to use CDI. I wanted to use Flyway because I want to automate my database migrations. What else did I choose? Let me get JSF too. I want to add JSF to my micro profile, to my Wildfly Swarm implementation. If I just generate my project, it's going to be ready to go. It already provides a REST endpoint for me to be using. I can import here. It will create a new project for me. And you can see the pwn.xml is kind of small. It just provides me a plugin, which is responsible for the magic of provide me a fat jar implementation. And the cool thing about the Wildfly Swarm plugin is that it checks which kind of dependencies that your code uses. So it's just going to pack the right things. If you don't use JMS, it won't be providing for you, even if you have here other kind of stuff. So I have here, so I provided Flyway, JPA, JSF, and CDI as my dependencies. I won't be able to configure everything else because it takes some time. So luckily, I have one project ready to go. And the thing that I wanted to show you here regarding my implementation is that I have already implemented another entity, which is called person. It also has a name and a surname as properties. And I wanted to show how does it behave when I'm trying to run that into a JSF application, which doesn't matter. It's just a view technology. But the important part is how do I map my domain model to the view, and how do I make efficient queries in the database using JPA, using a rich domain model. So let's try to run this project. So it's packaging, it's assembling a Wildfly Swarm jar. And it always takes longer when we are in a hurry in a live demo. Okay. It's running. Let me check my interface. So here is the interface that I provide to you using standard JSF. It has some person saved, has me, has Burr. I don't know how many of you play table tennis here. I was expecting more, honestly. Okay, because Sweden, I've been playing table tennis for like more than 20 years, and I used to be a very huge fan of Jan Waldner, Johan Persson, when I was a kid. I was hoping to find them somewhere near Stockholm, but I guess it's the same as asking, I want to meet Pelé in Brazil, or Neymar, or something like that. So it won't be easy, but it's just very simple. So what do you need? You need a controller, you need some queries, issuing JPA queries to my database, you need a form to provide the fields that you want to search. So the basic implementation here that I provided is, so I'm going to have here a person controller. And a person controller, it has a person form, which I provide here. It has string name, string surname. It's very basic stuff with just getter and setters. In this case, I can avoid to have public getter and setters because the information, the JSF requires me to have these getter and setters to be changing information on the screen. So here, I'm going to add the person controller. And what happens when I try to create a query? I could be creating a query using JPK, the stringy thing, which I don't like, which is not type safe. So I think there's a very cool project called Query.sl, which allows you to create queries in databases using JPA, using a very neat DSL. So the cool thing is I can create a JPA query. This is a Query.sl class. So instead of typing that, I can create queries this way. Query from the person, which is auto-generated by a Maven plugin, where, for example, the person form.getName. I can get person.name. Can say that it contains ignore converted to value to string, contains ignore case. What? The form dot get name. That's one of the cool things that I could show you. I'm going to break here because the line is too long. And I'm going to fetch. And it returns a list, okay? I could be just doing this. That's one way of creating a query for your DSL. It's type safe. If you run it, when you compile that, you know if it's okay or no. That's a working JPA query or not. But this code will fail because this code does not allow null values. So I would have to check, did anybody fill any information? So if I get here, if I don't provide a name or a surname, is it going to work? Probably not, so I have to check each one of these things. So if I want to query by the person name, I would have to check if form get name different than new, then I could be using this. I'm going to make a very ugly code. So, or else I could be creating a query, or else return query.fetch from person.person, okay, with no where. But you see, I just querying for name, but I also have surname, and this is a very simple form for issuing queries. Maybe I have like 10 different fields. I don't want to be checking for null for all of them because I'm going to forget. Maybe I want to compose something richer. Maybe I want to use, sometimes I want to use AND conditions, sometimes OR conditions, and everything else. So instead of just trying to check null here, why do I have to use primitive types in my forms? So here, I want to show you a different way of using that. I've created other classes, which the code is available on GitHub and on Maven Central too. I created a custom type for my queries too. I created a single string argument, which is a class that I won't be able to show you the source code today, but it's available on GitHub for you to check. And it integrates with Cured.sl for you to create it. So now if I create here, I don't like nulls, so I always provide a default value. It represents a single string argument, and I'm going to provide here the getters and setters for the information. So that's everything that I've changed in my form. Now I have custom types here in my query form too. I'm going to open the person controller. Now, instead of just trying to find if different than null and providing that information or everything else, maybe I can create my query just by doing this. I'm going to create a Boolean builder, which is a builder implementation for many different predicates of queries. And I can use that if I want to form .getName.append builder, and where do I want to query? I want to query person name string value, okay? And if I want to do the same, I can use surname here. So I have the builder, so carry where, so my code can be as simple as this. But you can argue this code is not that beautiful because I'm getting the form, extracting the information. Oh, sorry, here's get surname. Extracting information and creating the query here. Maybe the class responsible for creating this kind of this is the class that has this information. So I should be doing that not here, but in another place, maybe in parser form. So maybe I just could be getting this code, parser form, and maybe I could be creating here a method, public predicate to predicate. Maybe I could be creating here, and stat name, surname, that's too many getters, return builder. Okay, maybe I could be using this kind of construct in my code. So instead of be doing this, I could be just using query where form to predicate, and it should be working too. Let's try to see in my last 2 minutes. As again, it always takes longer when you're live coding. With this awkward silence when everybody's expecting it to fail. Okay, let's see. I think it's running. So here I have the same code again. It's going to work if I want to check here. My name, yes, it's filtering. Surname, here, it's working too. So that's one of the things that you can do. Instead of just, and the pattern, if I can say that I used here in my parser form to avoid to try to create like null instances, check different null conditions, is a null object. So sometimes Union types are useful for some use cases. Sometimes optional is a great solution in some use cases. And for other times, in this particular case, when you always assume that you're going to need an instance of the class, new objects probably are the best solution. And for that, I could provide you the single argument converter. Okay, which is just the source code, which is available on GitHub. I just provide a faces converter, which allows me to convert the string that is on the view to my custom type and back and forth. So that's my implementation. Okay, so that's some of the considerations that I wanted to show you today. Usually I present these in a full-day workshop, creating a domain model, creating some classes, different use cases, different technologies. But I wanted to show you some tips and tricks. I have more code available on GitHub, and I hope that it has been useful to you. And just as my final words, another cool project that you might want to check if you want to dig into the rich domain model words to create more immutability. Immutables, we have different immutable constructions and frameworks to provide immutable classes for us. I think immutables so far is my favorite. If you're trying to enrich your model with new kinds of collections, new Lambda code, new streaming code, maybe JavaSlang is a very cool library for you to take a look to. I don't know if anybody's coding. And I always like to end my sessions saying that we should care about what we do because we have a great responsibility in this world. Nothing will happen in the next 1,000 years without a developer behind it. So if you're going to find the cure for the cancer, the cure for poverty, the cure for ignorance, which is kind of widespread these days, it's going to be because a developer helped to achieve it. So we can make a better world with better software. That's all I wanted to say to you. And if you want more information, I would like to invite you to join developers.redhat.com. We have nice and cool T-shirts here on our booth, so you'll be able to get these T-shirts. And I would love some feedback at my Twitter handle. Thank you very much.